Implicit differentiation comes when we need to derive an equation that's implicitly defined. So for example, we have been looking only at explicitly defined functions so far, which is when we can really solve for y. When we can't solve for y, or maybe we just don't want to because it's easier in another form, then we have an implicitly defined function. So for example, something like 2x cubed plus 3y cubed equals 9xy. That would be very complicated to solve for y, and it would look not very pretty. So we keep it in the form that it's in and define implicitly, which means the y is kind of embedded in there. I can't isolate y. Then I have an implicitly defined function, and I can use these techniques to differentiate it still. So for another example is this graph. So how is this function, number 1a, how is this defined implicitly or explicitly? Well, the way it's shown right now, it's not solved for y. Y is not isolated on one side. So this is an implicit equation. You might recognize it. This is actually an equation of a circle with the center at 0, 0 and a radius of 1. Just as a reminder, a circle equation the equation for a circle is x minus the center, the x coordinate of the center, y minus the y coordinate of the center equals the radius squared. So this is, in fact, a circle with radius 1. If I want to make it explicit, I could solve for y here. And if I do, I would get this. And now this equation is solved explicitly, or written explicitly. This is really two equations though, right? There's the y equals radical 1 plus x squared, a positive. And there's also y equals negative radical 1 plus x squared. We have to do that because when we take the square root, when we solve for y, when we take the square root, then we also have to add the plus and minus sign. And the reason this comes out in the graph is because this is a circle, so it's not actually a function. All these numbers are actually defined two places. So, whoops. So what does that look like graphically? So if I have a circle of radius 1, okay. So this is a circle of radius 1, centered at 0, 0. The red equation is really just showing the bottom half of the equation. So this part of the equation is the y equals negative radical 1 plus x squared. And the blue part is showing that positive equation where y equals positive 1 plus x squared. So even though we were not given a function, we're given a circle, we can split it into two separate equations and get two separate functions. And that's how we solved that one explicitly. So this was already done for us, but say we were given this equation and asked to solve it explicitly, how would we do that? just solving for y, starting with x squared plus y squared equals 1, solving for y, so subtract x squared from both sides, and then when I take the square root, if I'm the one that takes the square root, then I also have to be the one that adds that plus and minus sign. So that gives us that explicitly defined equation. So some examples of things that are defined implicitly that give us some really beautiful graphs. These are all done in Desmos. And you can see these equations get quite complicated and make really beautiful things. But, of course, I could not solve for y because none of these are functions. So that's implicitly defined functions.